Hey everybody! Today we're going to talk about two more points of concurrency. Yesterday we talked about the circumcenter, which was made up of perpendicular bisectors, and we also talked about the incenter, which is made up of angle bisectors. Today we're going to talk about medians and altitudes. We're on page 13 in your packet. Make sure you're writing these down. So first of all, it's important that you know what a median is, all right? So it's the segment from the vertex to the midpoint of the opposite side. So let's take a look. I would say, let's look at CB. The midpoint, I would say, is about there. Okay, it's not perfect because we're just kind of freehanding here. So if I wanted to draw a median, the median, since it's going to the midpoint, will cut this side in half, and it's connected to the opposite side, the opposite angle. So that is what a median looks like, and you could draw a median from any of these sides. Now, if you were to draw two of the medians or all three of the medians, the point where they cross is called your centroid. So that's the next point of concurrency that we'll talk about. So we've talked about circumcenter, incenter, now centroid, and that is made up of the medians of a triangle. And it's also considered the balance point. If you were trying to, say, balance this triangle, this flat triangle on a pencil, the point that you would find works is your centroid. Makes sense, center, centroid. So let's take a look at what this would look like. So let's say, again, this is about the midpoint. I'd say that's about the midpoint of that one. And we'll go there. So if you were to draw, and you don't need to draw all three, two will work because they're all going to meet in the same spot. So if I draw that median, and I go from this median to the opposite vertex, this point right here, which is where this will cross as well, is considered your centroid. All right. And there's something that happens with these line segments. This is kind of showing you the centroid theorem. It shows you that AP, so this big part, is 2/3 of the whole thing. I have an easier way to look at it. So let's go back up to this picture. If this is 1, the big part is double that. All right, so basically each one has 3 sections. The big part has 2, the little part has 1. All right. You could also use this, but I think it's easier to look at it in terms of sections. All right, so same thing up here. If this part is 10, this part's 5, and the whole thing's 15. So let's look at some examples. If Rx is 48, so if you look, Rx is this whole segment. Remember, it's broken into 3 sections. So if I divide 48 by 3, I get 16. So this little part is 16, and this bigger part is 16 and 16, which is 32. All right, so again, it's broken into 3 parts. So RW now, if we look, is 32, right, because that's the big part that has 2 of them, and WX is 16. All right, let's look at the next part of this. QW is 30. Now, if you notice, that's the big part, right? So that's basically 2 of these little parts. So if that's 30, the little part's 15, and the whole thing would be 30 and 15, which is 45. So QZ, the whole thing, is 45. Again, we did the 30 plus the 15. And then WZ, the little part, is 15. All right, so again, you could use these formulas. I personally just like to think of it as 2 parts. The smaller part has 1, and the bigger part has 2. All right, now also keep in mind, because these are medians, it's cutting each side in half. All right, so let's take a look at another example. If just like any other time, if you'd like to try this on your own and then check with me, you can certainly do that. All right, so ZW is 7. If you notice, that is a median, right? Because it's cutting this side in half, goes to the vertex. That's the little part, so the big part is 14. So it wants us to find KW. That's the whole thing. 7 and 14 gives us 21. LZ, well, let's see. LX, the whole thing, I'm going to switch colors here, is 8.1. From L to X is 8.1. So again, if you want to find just a part of it, divide it into thirds. 8.1 divided by 3, you can use your calculator if you need to. I've already calculated it, so we'll speed it up a bit. Is 5. Let's see, hold on. 8.1 divided by 3 is 2.7. All right, so that means this little part's 2.7. This bigger part is twice that, so it's 5.4. So LZ is 5.4. Okay. So again, why don't you pause the video, give these two a try? All right, so let's see. Point P is the centroid, okay? So we know that this is one section, this is 2. So if QN, that's the whole thing, is 33, and you want to find PN and QP, well, if the whole thing is 33, we're going to break it into 3 parts, so each part's 11. The little part's 11. This has 2 parts, so it's 22. So now take a look. PN is 22. QP is 11. That's it. All right, DE is 7. It wants us to find CD and CE. Well, CD is the little part. So again, this part is double that. So that's going to be 14. All right, so CD is 14, and the whole thing is 21. All right. Now, you can find the centroid of a triangle, and I'm going to show you how to do that now. Here are your steps. You're going to graph the triangle, find the midpoint of 2 of the sides, and then just connect the midpoint with the opposite vertex. You don't have to do this for all 3 sides, because where the 2 lines meet is where the 3rd line will meet as well. So you don't have to go through that extra work. So this again is finding the centroid or the balance point. All right, so if you have a triangle already, you can just find the midpoint and go from there. So why don't we start over here on this one? It's a little bit easier. So remember to find the midpoint. You know, it's probably easiest to count across here. So we have 2, 4, 6, 7, right? Half of 7 is 3.5. So we'll go over 1, 2, 3.5. So there's your midpoint. Now take a ruler or a straight edge, and you're going to go from that midpoint to the opposite vertex. So you just drew a median. All right, so find the median of one of the other sides. It doesn't matter which one. I'm going to look at EF. All right, so again, when you're doing this, see how far up and down and over you're going. I'm going to just do the outside. So to get from E to F, I'm going over 2, down 1, 2, 3, 4, 5, 6. So if I cut it in half, I'm going to go over 1, down 3, and that'll put me at my midpoint. All right, so now you just connect it to the opposite vertex. Oops, I didn't want to do that. With your straight edge. All right, because if you don't use a straight edge, it's not going to give you the accurate point. All right, so here is your centroid right there. So it's the point -1, 2. All right, if you have the plot if you have to plot the points, that's okay. So 0, 4, remember that's your x, that's your y. So since 4 is on the y value in your point, it's on the y-axis. Label it with the letter. -4, -2. And then 7, 1. Again, connect your points with a ruler. It makes it so much more accurate. Anytime you're dealing with graphs, and we'll be doing a lot with graphs, get used to using a straight edge or a ruler. Okay, so this one's a little more complicated. We don't have a nice flat side to deal with, but that's okay. Just pick any two sides. I'm going to say, why don't we look at AB right here? I'm going up 1, 2, 3, 4, 5, 6, 7, 8. Oops, jeez, where am I going? I am not going up 8. Oh, it's too early. Okay, let's try that again. We're going up 1, 2, 3, 4, 5, 6 over 2, 4. So if I'm going up 6 over 4 and I want to cut it in half, I'm going to go up 3 over 2 to get to my midpoint. And then we'll connect that to the opposite vertex. Oh, that's nice. It's straight across. All right, so now just pick one of the other sides. It doesn't matter. You will be dealing with a decimal, either one. So let's just take a look at an example. You can still do it. And again, I'm going on the outside of the triangle to get from B to C. So I'm going over 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, up 3. So up 3 over 11. But if we divide that in half, we're going to go up 1.5. That's okay. We can still see that on the graph. And then over 5.5. So from B, I'm going to go up 1.5 over 2, 4, 5.5. All right. So now when we go to connect the lines, oops, what am I doing today? We're going to connect your midpoint to the opposite vertex. Draw this line again. It's a little bit off, but that's okay. So it looks like your centroid is right here at 1, 1. Now, that's the graphing way to do it. I have a much faster way to do it. I think you'll like this much more. You know, you're dealing with midpoints. If I gave you these 2 points, if you wanted to find the midpoint, you'd add them and cut them in half. Basically, what you're going to do is that same strategy. If you add all 3 x values and divide by 3 and all 3 y values and divide by 3, you're going to find your centroid, your center. So I'm going to take 0, 4. I'm going to line up the other two underneath it, -4, -2, and 7, 1. This is the exact same example from above, okay? So we're going to add all of our x's together. 0 plus -4 plus 7 is 3. -2 and 1. 4, -2 and 1 gives us 3 also. And then because there's 3 points, we're going to divide by 3 to find the center of all of them. And you get the point 1, 1. The same thing that we got by graphing it. So now let's look at the next one. These points I wrote down for you. Let's see if we get -1, 2. All right, so we have -5, 0, 0, 6, and 2, 0. Again, we're just adding all 3. So -5 and 0 and 2 gives us -3. 0, 6, and 0 gives us 6. Divide by 3. -3 divided by 3 is -1. 6 divided by 3, 2. The same thing that we got above. All right, go ahead, try the next 2. Again, it helps to pause the video first, then start it to check your answer. All right, so negative 8, 0, 0, 0. Add them, so we have negative 15 and negative 6. Divide by 3. So you should have gotten negative 5, negative 2. And the last one, 0, 0, 1, 3, and negative 2, 0. Gives us negative 1 and 3. Divide both of those by 3, and we get negative 1/3 and 1. That would have been really tough to see on the graph. All right, so that's it for centroid. Now we're going to talk about the orthocenter. We don't spend a lot of time on this. I'm going to just talk about it briefly today. Orthocenter is made up of the altitudes, and altitudes are just another name for the height. Oops. Come on. So basically, the height, remember, the base and height of a triangle have to form a 90-degree angle. All right? So if I start here, I want to go straight at this guy so it forms a 90-degree angle. All right? If I started here, I'd want to go straight at this side to form a 90-degree angle. The point where they intersect is called your orthocenter. All right, so this is the one you're typically going to see right here. If it's a right angle, your heights meet at the right angle. That's the only type that they typically ask about. All right, but if you wanted to find it, just plot the points. All right, we're not going to worry about this one. We're only dealing with right angles with orthocenter. So negative 3, negative 4 is J. Negative 3, positive 4 is K. And 5, 4 is L. Again, if I'm going too fast, pause the video, catch up. Don't try and do it all in your head. Or don't try and rush through it. All right. So where do the heights come together? Well, because it's a right triangle, they come together right here at your right angle. So your orthocenter is point K, negative 3, 4. Okay? And that's it for orthocenter, I believe. Oh, of course that didn't show up. Okay, so if you go to the next page, I told you before, you're probably thinking, how am I going to keep all these terms straight? Well, take a look at page 17. This is a very helpful page for you. Just bear with me. I'm going to a different page. This is a sentence. If you remember this sentence, it will help you remember all of these. Peanut butter cookies are better in milk, chocolate, and Ovaltine. I know it seems like a silly sentence to remember, but if you do, you'll keep all of these straight, or it'll at least help you with that. So peanut butter cookies are better in milk, chocolate, and Ovaltine. So peanut butter cookies. Perpendicular bisectors circumcenter. So peanut butter stands for perpendicular bisector and circumcenter. Are better in angle bisector in center. Angle bisector in center. So the peanut butter cookies, the perpendicular bisector. So if you draw perpendicular bisectors from each side, it makes up the circumcenter. If you draw the angle bisectors for each angle, where they meet is your in center. Okay? And then just remember, you've got your properties here that talk about, if it's made up of the perpendicular bisectors, it's the same distance to the angle. If it's made up of the angle bisectors, it's the same distance to each side. All right, are better in, and then we've got our milk chocolate and Ovaltine. And if you've seen A Christmas Story with Ralphie, he's just looking for his Ovaltine. Well, he's not happy about it, but so milk chocolate stands for median centroid. Oops. Milk chocolate. And then and Ovaltine, altitude, and orthocenter. I know it sounds silly, but these things really do help. So I want you to memorize this sentence, or you're not going to get to use your notes like we did with proofs. So peanut butter cookies, perpendicular bisectors is your circumcenter, are better in angle bisectors in center, milk chocolate, and Ovaltine. All right. So homework tonight is going to be page 18 and 19. I'm going to actually fix this a little bit. On page 18, you don't have to do the bottom. I did not give you enough information. And then on page 19, you're good to go there. And then I would like for you to just do on page 20, number 16. So you're not doing this one, just number 16. So again, homework is page 18 through 20. Pages 18 through 20. And again, you only have to do 16 on page 20, so just one graph. And you could just use the shortcut if you want. And then this is just 2 questions, and you don't have to do that question on the bottom of 18. If you have any questions, stop and see me or stop by the math lab. Have a great day.